in big, bold, beautiful letters on top of your paper, please. Triangles. 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 We have two different ways. We're talking about classifying now. How do we classify? In other words, naming them. And we can either classify triangles by their sides or by their angles. So make sure when a book asks you which one you're doing the right one, because it's easy to get those confused. What are your three choices, Maggie, when you talk about a triangle sides? What are your three choices? I'll give you a clue. They could all be different. All sides not equal. That's kind of a goofy way to say it. Or you could have, Maggie, all sides equal. Or you could have two sides equal. Three different choices. Okay, no sides equal, which is a better way to say this, which looks like this. If no sides are equal, that is called a, somebody? Rhymes with Kayleen? Scalene. Scalene. No sides equal is scalene. Whereas if all sides are equal, and by the way, in math, you know, because when you sketch things, because they're not always going to look equal because you're not that good at sketching, if you put a little slash like that, that means all three sides are equal. And when they're all three sides are equal, there it is what type of triangle? Yes, it is. It's an equilateral. It's an equilateral triangle. Now let's stop there just for a minute there, because equilateral triangles have some special little things that are true about them. Besides all sides being equal, guess what?
What?
Kayleen?
They all have equal angles.
Right, all the angles are equal as well. And guess what each angle is? And that's your cue. Guess what each angle is?
What?
What? How much would each angle be, Brooke? If you have a triangle who always adds up to 180 degrees, and all three angles are equal, what does each one have to be? Yes, but it's a certain exact measurement of an acute angle. Taylor? Yes, but it's a certain measurement that is less than 90 degrees. Noah? Yes, 60 degrees. Children, the beauty of this is this. No matter what size your equilateral triangle is, maybe it's this big or this small, these are always going to be 60-degree angles. Could be the world's largest equilateral triangle. Each angle will still be 60 degrees. Okay. And then the last one we have yet to speak of is this one here that has two sides equal, and that looks like this. And you'd have your little slash marks there. That is an isosceles. Isosceles triangle. And a little side note to that as well is that not only are two sides equal in an isosceles triangle, but the angles that are opposite those two sides are equal. Angles opposite are equal. And you're going to say, so what, Logan?
So what?
Well, the beauty of that is this, children. I should get rid of this guy here. Can I get rid of him? I will get rid of him. The beauty of that is this. If you have an isosceles triangle, let's say this side and this side are equal, and I tell you that this is 40 degrees, you can right away tell me that each one of these angles is what? And don't say 40 degrees, because they're not. Knowing that in an isosceles triangle, the sides opposite the equal, the angles opposite the equal sides are equal. These two angles have to be equal. So how big do they have to be in order to give me 180 total degrees, knowing that this one up here is 40 degrees? Doing the math, Ryan says
70.
correct, because I know these two have to equal 140 degrees to give me my 180. Cut 140 in half, and each one has to be 70. It's all these fun little things about triangles that make them special in your life, aren't they? Good point. Good point. Now, let's look at that. So this is classifying by their sides. Now by their angles. And there's really only 3 different ways we classify them by their angles. And they would be like this. They either have all acute angles, which looks like this. Acute. Acute, I don't like that one. Can we have a do-over there? Let's just do this one. All acute angles, which means it is a, and I know this is a hard stretch for you, if they're all acute angles, then it is an acute triangle. I know that's hard to imagine. You can have a triangle that has one obtuse angle in it, like this. This one's bigger than that. And I know it's a struggle. Guess what that's called?
Obtuse triangle.
An obtuse triangle. And the other one is you can have a triangle that has one right angle in it. And I know that's going to be tough for you to know as a right triangle. All acute, one obtuse, and a 90-degree angle. If you can make a triangle that has more than one 90-degree angle in it, let me know, because man has been trying for thousands and millions, if not billions of years. No, that's not even true. Let's just go thousands of years. Set the emphasis there. Yep. Everybody's happy with that? Because we've got more to do. Alright, now, what about, still under triangles, what about how to find area of triangles? What is our formula? What is the formulae for area of triangles? For some reason it's a tough one. Most people get this wrong at least once or twice. Alex says
Side, right side by height. No, next.
area equals, Grace, 1/2 times the base times the height. And usually we don't write out all those words, we just abbreviate with letters. So it looks like this, area equals 1/2. Usually it's B. H, is it small b? What is it? Hold on a second. I just want to make sure I get this. Now, small b, small h. Now with that, ladies and gentlemen, we must understand some things here. Let's say this is 8 inches, and this is 10 inches, and this is 10 inches. What is the area of that triangle? Anybody want to venture a guess? Fire a guess at me, Stupford. Wrong. Somebody else want to guess one, Maggie?
40.
Wrong. Somebody else want to guess one, David? Wrong. Logan?
80.
Wrong. Ryan?
You don't know because we don't know the height.
Oof, finally, after all these years. I always start with that because that's what most people do to me, and they throw out those numbers here. You must understand this, write this down, children. The base and the height must be perpendicular to each other. In other words, they have to form a right angle. And if you look at my three sides of this triangle, where do you see the right angle there? The correct answer is there is none. So in this case like this, for a triangle like this, you cannot find the area unless the book gives you, and it will, it'll draw a nice little dashed line from one side to another side from a point, and they'll draw a little corner in there that stands for right angle. And they'll tell you, oh, this is 8 inches. And now I can find the area of it. What's going to be the base? What's going to be the height? Well, we usually call this the base. The right angled line that goes straight up is the height. So area equals 1/2 of 8 times 8. Half of 64 is 32, thank you very much, inches squared. Do you have that? There has to be, if you're asked for area, perimeter, no. Perimeter, you just add up the sides. But area has to form right angles. Has to form right angles. Okay? Let me give you another example. If I was given this triangle, if I was trying to find the area of that triangle, area equals 1/2 base times height. What is the base and what is the height? Base and the height would be Belanuzo? Is what? Give me the two numbers I would use for the base and the height. Right. See this little square corner? That's what you look for. You find the right angle, and this one I don't need a dash line because two of the sides. This is a right triangle. You just use those two. So it's 1/2 of 15 times 6. 6 times 15 is 90. Half of 90 is, this one would be 45 inches squared. What about for this one? Say this is 6 inches, 12 inches, and 11 inches. Base and the height on that one would be, Caleb? Just give me the two numbers I'd use for the base and the height. What's that? Thank you. We can't do this one because there's no right angles there, so you got to, the book will have to do this. Sometimes it'll look like this, and they'll come out here and draw a straight line down like this and put a little right angle there, and they'll say that this is maybe 10 inches. Now what two would I use? This is 10 inches here. This is 11, 12, and 6. What two form the right angle, Cameron? Correct. You got the 10 going up here, the 6 here. It doesn't matter what this little line is here. They're still right angles with each other. So area equals 1/2 base times height. 1/2 of 6 times 10. And that is, what, 30 inches squared. Hasn't this just been refreshing? So I wish you had me all day long.
Yeah.
That would be nice. Perfect. Take a look at page 129, please.